to the distributive property. We talked about this earlier this year, but I want to review it again, bring it back to your memory. Okay, and we'll do some examples using it today. First off, the distributive property. I'm going to look at the algebra. That means the letters, not the numbers. Okay, so if I have A times this quantity, stuff inside parentheses is called a quantity. Okay, but Lily, let me ask you something. Looking at this first one here, inside those parentheses, how many terms are there? 2. So I have to multiply the A by both of those terms. A times B plus A times C. Easy enough. Bennett, let's look at the next one. The A, though, is in the back. Does that matter? No. It still gets multiplied by both of these terms. This should be A times B. We always write variables alphabetically. That should be AC. Easy enough. Does it work for subtraction too between the two numbers? It does. It's going to be A times B minus A times C. Okay? Or from the other side, A times B minus A times C. Everybody happy with that? Yeah. Now I want to do one example over here. Okay? And I want Cedar for you to help me with this one. Cedar, let's look at the third one here. Okay? Now, let me ask you something, Cedar. What is 7 minus 2? It's 5, right? And so what would 5 times 5 be? 25. So I know that I'm looking for the answer of 25. Do you agree? Okay. But let's do this. Remember, this is 5 times 7. Okay? And what is 5 times 7, Cedar? It's 35. Okay? And then minus 5 times 2. What's 5 times 2? 10, right? Okay, but what is 35 minus 10? Good, it better be, right? So the distributive property gives us the exact same answer. Now, if I have numbers inside the parentheses, I'm going to go ahead and combine them, because that's the first thing I'm supposed to do, is deal with the parentheses. But as you guys know, sometimes I don't have just numbers in the parentheses. Sometimes I have variables in there, and I can't put them together. But I can multiply into the parentheses and get rid of them. All right, so let's look at this first example. Okay, let me scoot down here. Now, example 1. Casey, it says you and a friend are going on a camping trip. That's nice. You each buy a backpack that costs $90 and a sleeping bag that costs $60. What is the total cost of the camping equipment? Now, let me ask you, because I know we can do this simple, but I want to do it in a certain way. All right. So Casey, how would you find out what one person pays? So 90 for the backpack, right? Plus 60 for the sleeping bag, right? But how many people are there, Casey? There are 2 people. So I want to take this cost and multiply it by 2. Casey, perfect. Now I'm going to go over to Gray. Now Gray, let me ask you something. Normally, I would add these 2 things, right? Because I can.
But the distributive property.
But I just want to show the distributive property, so let's work through it that way.
So you do 2 times 90,
which is
180.
Nice. And then
You do 2 times 60, which is 120.
good. And what do I get together?
You get not 200 here, 400.
Not 400. There you go, 300. Because look, you got 100, 100, and then 80 and 20, which is another 100. So we get 300 total. Piece of cake. Simple stuff. Okay? When you're doing things mentally, sometimes it really helps the distributive property. For instance, 3 times 16. Okay? That's 3 times 10 plus 3 times 6. What is 3 times 10?
30.
What is 3 times 6?
18.
30 plus 18?
48.
Good. That's the distributive property. 3 times 10 plus 6. Right? What if it was this? 3 times $4.99.
Hey, I know.
Hang on though, Gray. You've had a chance. Allison?
Would it be 3 times 4 and then 3 times 0.999?
I don't know know if I want to do that one, although it would work. It's kind of complicated. McV?
You do 3 times 5.
3 times $5 minus 1 cent. What's 3 times $5?
15.
What's 3 times 1 cent? 3 cents. What's $15 minus 3 cents? Right? So instead of trying to do that, we can just do that. Right? That's easier to do in my head. Okay? Just using the distributive property, right? 3 times 5, 3 times minus 0.1, right? Gives me 15 minus 3 cents. Luke.
On the homework, would you
Yeah.
want us to like write it out so like do?
I'm going to want you to do it mentally and then show me by writing what you did mentally.
Okay.
Okay? All right? So you're not going to be using a calculator when they ask you to do it mentally. But you can show me, you can write down what you did mentally, just like I did here, right? Okay, let's look at the next one. Geodes. You remember seeing the huge geodes at the Perot Center?
Yeah.
Those things are beautiful. I know they're not that exciting. I mean, you don't go, oh my gosh, I got to go to the geodes. But they're really cool to look
You
at.
can open up the
It's as big as a room. That thing's huge.
Wait, what's a geode?
A geode was the
Rock
huge
and
crystalline rocks, right? And it was, they had different colored ones like pink and purple and aqua, and they're very cool stuff, you know.
Yeah, you like crack them up.
So, after touring a cave, you visit the gift shop and buy 3 geodes. Okay? Each geode costs $5.95. Use the distributive property and mental math to find the total cost of the geodes. How would you set up a distributive property problem with this, Catherine? 3
And then
parentheses.
5. I would do $6.
I'm asking you to go ahead and break it apart.
I'll do $6.
$6 minus 5 cents. Right? Just like that. Now, Catherine, let me ask you, what is 3 times $6? So that's $18. And what is 3 times 5 cents? Minus 15 cents. So how much did it cost us?
41.
Beautiful. We didn't need a calculator, right? Just use the distributive property. It's easy to multiply 3 times and make 1. Right? Excellent. Good. Let's look at the next one. Oh, these are easy. Raise your hand if you want to do one. Great. You get the first one. You're the first hand I saw.
Okay, so what I would do is I would do 3, I would write it out, the whole thing, just,
Got it?
and then I would do 3 times x, which is 3x.
Yes, sir.
Times 3, no, 3 times 7,
And what is that?
plus 3 times 7.
Plus
And
3
then-
times 7, which is?
Sorry,
3 touchdowns.
I know, I'm sorry.
That's okay. Relax. Relax.
21.
There you go. Nice. There you go. Beautiful. All right. Now let me ask you something because it's going to come up. Do you think that you can unmultiply that?
Yeah.
Right? I mean, we could. That's called factoring. Just like when we say that 12 is equal to 2 times 6. Do you see how I factored it? Okay. 3x plus 21 is equal to 3 times x plus 7. Do you agree? Right? I factored it. 2 things multiplied together that give me this. Just like that one over there. We'll talk about that later.
6 too.
You could break 6 down too.
Is that like the next section?
Oh, that's 8th grade stuff. But y'all are smart enough to deal with that.
I love factor trees. We learned that.
Yeah, last year.
We still use them in 8th grade all the time. I use them today with the 8th grade.
Is that
You're going to do the next one for me, Allison. What do you get?
Well, negative 2 times 4 is the first.
Can we do it like this? Can we go to that front number?
Yeah.
And the reason is because I want the one with the variable in the front. Okay. So negative 2 times n is
Negative 2n.
good. And then negative 2 times,
It'd be plus negative, right?
ooh, plus negative. Plus
Or,
negative.
sorry, negative, and then 8.
Perfect. See, you just did a negative 2 times a positive 4. So it gave you a negative 8. That easy. Just like we've been doing, right? Bennett, help me on the last one here.
Whoa.
So, first we do 5 times,
Not 5.
negative 5 times 2y.
Negative 5 times 2y, and what do you get?
5.
Okay. multiply what you can, right? Izzy? Which is? So it's negative 10y, right? Because I can multiply them. I can't add them when they're not alike terms, but I can multiply them. I've got negative 5 times 2y is negative 10y. Okay? Finish it off there for us, Bennett.
Then you multiply negative 5 times negative 3 and get 15.
And get positive 15. Beautiful. Do you see I could take a negative 5 out of both of those? Okay, just unmultiply it, right? Which is the same as what we call factor. All right? Nice job, last one. Really good job on that one. Really good. Okay. Find the area of the rectangle or triangle. Well, I put 2 up here. How do I find the area of a rectangle, Lily?
The area of the rectangle is
Base times height. So this times that. Okay, well good, let's do that. Tell me what to write.
okay. Well, do 2x plus 5
Mm-hmm. Do you want me to write 7 behind or in the front? Does it matter? Doesn't matter. I'll write it up here because that's the way we normally see it.
Yeah.
Okay, so what do I get?
Well, you do 7 2x.
And that gives me 7 2x's would be 2x plus 2x plus 2x, 7. Good, it's 14x, right? I don't have to repeatedly add, I just multiply and get 14x. And then what? Beautiful. Positive or negative? Positive. Awesome. Awesome. Okay. Who wants to do the next one for me? Lou, I haven't heard from you today.
It's-
Lou, what's the formula for the area of a triangle?
Base times height divided by 2, or times a half.
Okay, I like the times a half, and you'll see this is going to help us a lot.
Yeah, that's a fraction.
Exactly. So, A is equal to 1/2 times the base times the height, right?
Yeah.
Okay.
So,
So
we should do
1/2
1/2
times,
yeah, there's 8 minus 3y. Wait. 8 minus 3y.
why don't we do the base?
Oh, wait, 12.
I'm just saying 12, okay? And then times
8
the-
minus 3y.
8 minus 3y. Okay? Now, let me ask you something, Lou. How many things am I multiplying here?
You're multiplying 4?
Not 4.
3.
There are 3 things that are being multiplied, right? This times that, right? A half times a base times the height. 3 things. Which 2 things would you like to multiply first?
A half to 12 would be 6.
Exactly. That's the easiest thing. Area is equal to a half times 12, which is just 6 times 8 minus 3y.
Now it's
Yeah, now we do this.
Now it's easy.
Yeah.
Okay.
So,
Let's see. Let Peyton finish this up. Peyton?
6 times 8
Yes, sir?
is 48.
Uh-huh.
Then 6 times 3y.
It's not 3y, is it?
Or negative 3y.
Which gives me?
Negative 18y.
All right. Now, there's one problem. Oh, nice. Nice. Allison, what is that problem?
The variable has to come first. You do 18y.
I don't have 18.
Negative 18y, sorry.
Exactly. Remember, think of these as terms, right? That whole term has to move to the front. Negative 18y
Times 40, right?
times 48? What am I doing between these two things?
Oh, you're adding.
So it's just plus 48. That's it. Done. Perfect. Could not have done it better. Get started on your homework.
You're left